Hi, welcome back. In this video, we're continuing to talk about comparing means. In our last two videos, we have been looking at this example where we are trying to figure out what effect friendship has on simple sales. We did a hypothesis test on this well-controlled randomized experiment. In the first video, we started by checking our assumptions to make sure inference is okay. And we found that inference, a two-sample t-test or a two-sample t-interval of the mean are both appropriate. And we came to the conclusion in our last video that there is strong evidence that friendship does affect simple sales. So in this video, we are going to be talking about actually quantifying this with a 95% confidence interval estimate of the price difference. All right, so we are going to start, if this was the beginning of a problem, we would need to make sure we're defining our random variables, checking assumptions, pulling all of our sample statistics. However, because we have already done that, we don't need to do that again. So we are going to be able to just jump right into our confidence interval. Now, our confidence interval is going to be our best estimate, which in this case is the difference of means, plus or minus a margin of error. So our margin of error is going to be our critical value multiplied by the standard error of the difference of means, which we already know this. So what we're really focused on here is that t-star value. So we know that our confidence level is 95%. And I'm going to go through and show you, I'm going to go through with I'm going to do this by hand, and then I'm going to show you how I would do this using my calculator. So if we are finding our t-star value, we're going to use inverse t of 1 minus our confidence level over 2, and then the degrees of freedom. So if I am doing this by hand, I'm going to use my conservative degrees of freedom, which is 6. This is going to give me inverse t, 0.0256. This is going to give me 2.447. And we can make this the absolute value of this because it's going to be positive or negative. So this is my conservative value. If I am going to use the other value, this is 6.435 is my degrees of freedom. So let's pull that, 6.435. And I get 2.407. Okay, so now I'm going to look at my margin of error, which is going to be t-star multiplied by my standard error. So I'm just going to recalculate that just to make sure that I did everything right. 18.31 squared divided by 8 plus 89.993 squared divided by 7. And let's take the square root of that, and I get 34. So that is wrong. So my standard error is 34.625. All right, so my margin of error is now going to be 34.625 multiplied by one of these. So if I'm going to stick with my conservative. So 34.624 multiplied 2.447 is 84.727. So my confidence interval is going to be 281.875 minus 177.143, 104.732, plus or minus 84.727. So my lower limit is 20.005, and my upper limit is 189.459. So this is my conservative confidence interval. Now, if I'm going to use my calculator, I'm going to go to stat test, and I am going to scroll down to a 2-sample t interval. My data is in list 1, list 2, a 95 confidence interval. It's not pooled. And I hit calculate. It gives me all of my summary statistics, the calculator degrees of freedom, and it gives me 21.378 to 188.09. So this is my calculator. So this is going to allow me to add to my conclusion. So not only do I think that not only is there strong evidence that friendship affects sales, now my 95% confidence interval estimate can add to this. So to add to this, I'm going to say we are 95% confident that the true mean price offered to a friend is about $21.38 to $188.09 more than offered to a stranger for a camera. So not only do I think that there is some connection, but now it looks like people are more willing to offer their friends more money than strangers. I just want to point out the difference between the conservative and the calculator. Our conservative has a wider estimate than our calculator. So your calculator output is going to give you a slightly more narrow confidence interval than the conservative. But that's why this one's considered to be the conservative estimate. So that is our 2-sample inference of means, comparing means when we have independent groups.